Here is my third DER and first ISP of my grade 12 year, the Duckman NeoBlocks, a project in which the three pillars of the ICS 4U course come together: hardware, software, and design, to create custom adaptable Wi-Fi enabled RGB hexagons, or what I will refer to as blocks. Throughout this video, I will go over such pillars, beginning with hardware, then software, and finally design. Within the Duckman NeoBlocks, an elementary circuit can be found, consisting of Adafruit's ESP8266, an SMT 5V and 3.3V voltage regulator, an SMT blue LED, SMT 470 ohm fixed resistor, SMT 10K picofarad capacitor, SPDT slide switch, and of course the WS2812B strip RGB LEDs. For starters, an ESP8266 is used as the MCU for Wi-Fi capabilities, later explained within the software portion, and was vital due to the limitations of the Arduino IoT Cloud. To power the MCU, 3.3 volts was needed, therefore an SMT 3.3 voltage regulator was also used, and a 5V voltage regulator input to satisfy the WS2812B strip RGB LEDs voltage limitations. WS2812B strip RGB LEDs, better known as NeoPixels, are singularly addressable RGB LEDs that have 3 input pins. NeoPixels have an IC built into the LED, enabling communication via one wire interface, meaning that an infinite amount of LEDs can be controlled using just one data pin on the MCU. The LED strips have 3 pins: power, ground, and data. The power and ground pins are used to apply power to the strip, while the data pin facilitates the communication with the MCU, in this case the Adafruit ESP8266. The second portion of this project was the software component, in which Arduino's free and publicly available IoT Cloud was used to manipulate the blocks over a user interface on any device through Wi-Fi. First, a thing must be created to accomplish a fleet within the Arduino IoT Cloud. Things are essentially the trunk of the platform's communication and are used to link a group of variables to a sketch. Within such project, 3 variables were used: NeoPixels, a variable used to track the number of blocks plugged in; color, a variable used to control the RGB of the NeoPixels; and messenger, a string used to send messages users write to the sketch. Next, a dashboard commonly known as the user interface must be created, in which 3 widgets were used: number of blocks, a widget used to set up the number of pixels value within the code; color, a widget used to control an RGB display composed of 3 slide switches, one for hue, saturation, and brightness within the pixels; finally, messenger, a widget best described as the Wi-Fi version of Arduino's serial monitor. Through the messenger, values can be displayed using the integer digits within the code, housing every alphabet letter and every number. That said, it is not completed, due to a problem highlighted later within the video around reliability. The third and final portion of this project, and arguably most impressive, is the design component, consisting of 3D printing, PCB design, magnets, and last and most definitely least, the DuPont connectors. The 3D design in this project was intense, consisting of 3 major components: the NeoBlock, the connectors, and the diffusers, all of which play fundamental roles in such project. Firstly, the NeoBlocks is a simple and elegant design, consisting of a hexagonal shape that allows for elegant and versatile connections between blocks. Secondly is the connectors, which can be best described as one of the triangle portions of a hexagon and fits perfectly between the blocks to allow straight lines to be created. Lastly came the diffusers, used to diffuse the light for the NeoPixels to give off a more elegant look, and were printed using vanilla white and had friction fit with the blocks to allow for debugging when necessary. The second portion of this design was the PCB, as in the main block, a custom PCB was required to house the ESP8266 and all supporting components. The PCB for such project fit effectively using friction fit within the main block, preventing loose, unattractive noise while handling the block. Within the Duckman NeoBlocks PCB, 5 SMT components can be found and play an extremely crucial role due to the significant space constraints within the blocks. Next were the magnets, used in 2 different situations, playing a vital role throughout this build. The first magnets can be found within the blocks, used to create stronger connections within the DuPont connectors, and the second, on the back, allows the blocks to be connected to any magnetic surface such as a whiteboard. The fourth and final portion of the design was the 3x1 DuPont connectors. DuPont connectors, found commonly on jumper wires, or more specifically 3x1 DuPont connectors widely found at the end of servos, were used to connect such blocks, yet ultimately led to the downfall of this project. Despite a clean look, such connectors are highly unreliable and often need to be wiggled while connecting blocks together to transfer a clean signal, and made it nearly impossible to connect 7 of the blocks. Ultimately, despite the mishaps along the way and a final product that I was not looking for, I cannot be happier with the development and learning that came along the way with this project. Whether it be using such skills in the ICS4U course or not, I look forward to applying such knowledge in my future and am grateful for such an opportunity.